Hello Chem Nerds, welcome to the Balancing and Reactions review video. Here we're going to cover what chemical equations are, the types of reactions, balancing equations, and multimole ratios. This is essentially the minimum that you need to know for the upcoming IA. So we'll start with a chemical equation, and this essentially represents a chemical reaction to symbolize form. And to start off, let's start with this example right here. Ooh, that's not pretty. Let's start that over. Alright, so we'll start with this. As our example chemical reaction, where 2 hydrogen gas plus oxygen gas yields 2 H2Os, aka water. So with this as our example reaction, I'm going to show you the different parts of a chemical equation. So let's start with this part right here. This arrow pretty much separates the two sides of the equation. So it separates the reactants from products. And the way we read this is as if we say yields or produces. So 2 H2s plus O2 yields 2 H2Os. That's what we mean. And what do we mean by reactants and products? So this side over here is the reactants side. So these are the two things you need to start out with to make over here the product side. So reactants yield product. Reactants produce product. Exactly like that. Alright, next, we have these things over here. Oh, let me use a different color. Over here, and over here. So these over here are the coefficients. They represent pretty much the number of moles you need of this substance to react. So in this example we have 2 moles of H2 and 2 moles of H2O. Now if you notice for O2, there's no coefficient. That means that it's an understood 1. So you don't exactly have to show the 1 coefficient if there's only 1. It's understood to be there. So that's essentially the parts of a chemical equation. So we'll start with the 5 types of reactions, and here we have the 5 types: synthesis, decomposition, single replacement, double replacement, and combustion. To start off, we'll go with synthesis. So the previous slide showed 2H2 plus O2 to yield 2 H2Os. So this is what synthesis is. You take 2 substances to combine them together to make a single substance. Decomposition, on the other hand, we could take this example and reverse it. You take 1 substance and it breaks down into 2 or more substances. Single replacement now. This is where you have a free element and another substance, like a compound right here. And what this free element is going to do is going to sneak in and combine, break up that compound and combine with what's left. So you see how zinc here was free on the reactant side, and then HCl were bonded together. It breaks up the bond of HCl, zinc sneaks in to take chlorine, and hydrogen is now by itself. So think of it as a couple being broken up by a third person. So someone came in to steal that partner. Now double replacement right here. Here we have 2 different compound substances. We don't have any free elements. So instead, with double replacement, you think of it like 2 couples swapping partners. So example here, NaCl, AgNO3, they swapped partners. They swapped, and you'll see here, double replacement. Combustion is a special kind. I showed this in class by lighting a match inside the classroom. And so pretty much the requirement for a combustion reaction is to have an organic substance like CH4, like a match for example. Combine that with oxygen gas, oxygen's a requirement, and kaboom, you have a combustion reaction. And CO2 is a common product of this. so is water as well. So this is a classic combustion reaction example. Let me make a little note right here. This is the example of organic substance. So anything that is organic contains carbon. So CH4, methane, is our organic substance for this example. Alright, now we're going to get into balancing equations. This is kind of like puzzle solving. And so pretty much what balancing equation does, it shows that substances have to combine in specific ratios. And these have to be in, let me specify here, the smallest whole number ratio. Whole number ratio. So it's kind of like reducing things into empirical formula form. And this also, balancing equations follow the law of conservation, in which, right here, explained right here, mass, the number of atoms, charges, etc., they have to remain constant before and after the reaction. What do I mean by this? So, let's go back to our classic example right here. So 2 H2s plus 1 O2 equals, or yields 2 H2Os. So the number of atoms here have to remain the same on both sides of the equation right here. So this arrow separates reactants from products. So to sort of verify if this follows law of conservation, we're going to take our two types of elements here, H's and O's, and let's count them up. On the reactant side, we have 4 of them. On the product side, we also have 4 of them. Reactant side of oxygens, we have 2. And on the other side, we also have 2. If they check out, both sides are equal, that means it's balanced, and this follows law of conservation, in which the number of atoms must stay the same before and after the reaction. The mass, in order to show mass staying constant, let's say you have, for 10 grams of H2, and let's say we have 80 grams of O2. So if we have 10 grams of H2, 80 grams of O2, what does this mean? We have 90 grams of substance total before the reaction. That means after the reaction happens, we should still end up with 90 grams on the other side. 90 grams of H2O is being produced from this reaction. So that's what we mean by law of conservation, is that both sides, number of atoms, and the total mass has to be the same both sides of the reaction, both sides of the equation. Okay. Alright, so now let's go through an example of balancing an equation. And here are some basic rules before we begin. So first, you only change the coefficients, never the subscripts. If you change the subscripts, you change the substance. So we're only going to change the number of moles here, the coefficients. And also, you got to make sure that the total number of atoms and the total mass have to be the same on both sides. This is a way to check if your equation is actually balanced. And here we're going to run through this example of C3H4 plus O2 producing CO2 and H2O. Please note this is an unbalanced equation. Right now we're going to balance it together. And let's start with looking at C3H4. There are 3 carbons on the left side, and if you notice on the right side, there's only 1 carbon on CO2. So we got to balance this out. If we have 3 on the left side and 1 on the other side, we should put a 3 in front of the CO2. Now it checks out, 3 of carbons. Alright, now let's go back to C3H4. There are 4 hydrogens. On the other side, there's only 2 hydrogens on H2O. So 4 versus 2. How do we make that 4? We got to double it. Let's put a 2 in front of the H2O. Now let's check here about the oxygens. We only have 2 oxygens on the left side. On the right side we have, let's make note over here, we have 6 over here and 2 over here. So that makes a total of 8 O's. So that means we need to balance it with 8 O's on the other side. If we only have 2, how do we make it 8? We got to multiply it by 4. So let's put a 4 right there. Let's double check now. 3 carbons, 4 hydrogens, and 8 oxygens. There we go. That's it. Do we have to put a 1 in front of C3H4? We shouldn't. It's already understood that 1 is there. 1 mole of C3H4. And that's it. We have balanced this equation. Alright, multiple ratios. This is the last thing you probably need to know for this. So here's some rules. You gotta make sure the equation is balanced before you even attempt the problem. If it's not balanced, then you can't even check for multiple ratios because you'll be ending up with the wrong answers. Next, you're gonna use the coefficients to set up the ratios. So after you balance the equation, you're gonna use your coefficients to help you solve this problem because it helps to set up ratios. So let's go back to our previous example in the previous slide. C3H4 plus 4O2 yielding 3 CO2s and 2 H2Os. So let's double check if it's balanced. 3 carbons, 4 hydrogens, 8 oxygens. Okay, we're set. Now let's proceed on. If, for example, they want us to find the ratio between C3H4 and 3 CO2s. So let's say we have 10 moles of CO2. How many moles of H2O was also produced in this reaction? Alright, so we gotta figure out how many moles of H2O was produced alongside CO2. That means we need to first identify our two substances, CO2 and H2O. Next, we're gonna look at their coefficients over here. 3/2. So for every 3 CO2s, there are 2 H2Os being produced. Next step, let's take a look at our problem. We have 10 moles of CO2. So we put a 10 right here. We're looking for moles of H2O. So we put an X there because that's what we don't know. Next, this looks like a proportion, so let's set that up and solve. So 3x is equal to 2 times 10. 3x is equal to 20. And so x is equal to 20 divided by 3, which is approximately 6.66 repeating moles of, let's be specific here, H2O. And that's it. That's how you do a multiple ratio problem. Now there's a little bit more we've learned in class and regarding mass calculations with chemical equations, but you don't need to know that for now for this IA. Alright, I hope that was helpful for you guys, and good luck studying. If you want to look back on the old stoichiometry video, please do so if you want to review the old topics that are definitely going to show up on this IA.